Welcome back, everybody. I am Travis with Linux Academy. In this lesson, we're going to start delving into the components and theory of Docker networking. I think it's a pretty fair assumption that when we go and create a container, it's either going to communicate with another container, or you have an application that needs to be accessible by the internet. Let's take a high-level overview of how networking works in Docker. There are three major components that consist of Docker networking. The first one is the container network model. The CNM is a design specification, and it outlines the fundamental building blocks of a Docker network. The second component is libnetwork, and it is the real-world implementation of the CNM. And ultimately, this is what Docker uses. And this is the implementation that Docker uses for connecting containers. Libnetwork is also responsible for service discovery, ingress-based container load balancing, and the network and management control plane functionality. Now, libnetwork uses a system of drivers. Drivers extend the model by implementing specific network topologies. The first driver we have is bridge, and it is the default network. A bridge network is a link layer device which forwards traffic between network segments. The bridge driver uses a software bridge which allows containers connected to the same bridge network to be able to communicate. It also provides a layer of isolation from other containers that are not connected to that network. As I previously mentioned, the bridge network is the default that is used anytime you go and you create a new container. Also, this driver only works on Linux. So if you're wanting to use it for Docker Desktop for Mac or Windows, you're out of luck. Anytime we want to create a distributed network among multiple Docker hosts, we're going to be using the overlaid network driver. A really good example of when this is going to be used is when we start working with Docker Swarm. The Mac VLAN driver allows you to assign a MAC address to a container, and this gives it the appearance of being a physical device on your network. Now here's a couple of use cases where using the Mac VLAN would be pretty useful. Sometimes when you have legacy applications, or if you have an application that monitors networking traffic, and those applications are expected to be physically connected to a network. Other than that, I don't really see a lot of circumstances that you may encounter where you're going to be required to use the Mac VLAN driver. Now, there may be a few circumstances where you want to go and disable networking, and this is where the none driver comes in. Normally, you will use this driver in conjunction with a custom network driver. Also, it is worth noting that you cannot use none with a Swarm service. And finally, we're also able to use third-party network plugins with Docker. And you can find out what plugins are available to you over at Docker Hub. Now let's take a closer look at the container network model. So far, we've learned that the CNM is the specification for Docker networking, and it goes and defines the fundamental building blocks of a Docker network. And there are three building blocks that are going to be spelled out here. The first one is the sandbox. The sandbox isolates the network stack. This is going to include the networking interfaces, ports, route tables, and DNS. Endpoints are virtual network interfaces, and it's the responsibility of the endpoint to connect the sandbox to a network, which is the third building block. And these networks are software implementations of the 802.1d bridge. This diagram illustrates how the CNM components relate to containers. If you look inside both container A and B, you can see that we have the sandbox component. And this is what provides networking connectivity for our containers. Container A has a single endpoint. And again, this is our virtual interface. And that endpoint is connecting to network A. Now on container B, we have two endpoints, one connected to network A and the second connected to network B. Now, because both container A and B are connected to network A, this allows both containers to be able to communicate. However, in container B, both endpoints are not able to communicate with one another unless there is a layer 3 router involved. Because endpoints behave like real-world network adapters, they can only be connected to a single network, which is the reason why container B requires two endpoints to be connected to both network A and B. Even though both container A and B are running on the same Docker host, their network stacks are completely isolated from one another. Coming up in the next lesson, we're going to start getting familiar with the Docker networking commands. So go ahead and mark this lesson complete.